All right, does this work? Yes. Okay, well, is the timer starting? So that I can keep track. Thanks. Cool, thanks. Thank you. First of all, thanks for being here. There must be a really popular talk somewhere, I guess, because well, maybe people will show up later. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And today I'm going to be talking about Knative and Cloud Run. But before I start my talk, if you go to this GitHub link, you already have my presentation, and you already have my all the demos that I'm going to show today. So you don't have to take any pictures except this QR code if you want it. I also have a Twitter account in case you want to follow about cloud native, Knative kind of topics. That's my Twitter. All right, let's do a little bit of introduction on Knative. Knative, it's a Kubernetes-based open source building blocks for serverless. And anyone here running Kubernetes in production? A few people, yeah. So if you know Kubernetes, this sentence does not actually make sense, because in Kubernetes, you have nodes where you schedule containers to. So it is with servers, it's not serverless, but that's the whole point of Knative. It tries to make Kubernetes, it tries to turn Kubernetes into a serverless framework. That's the whole point. And we'll go through the presentation and see how that works. But first, I want to define what I mean by serverless a little bit, and I want to talk about Kubernetes just a little bit, so we are all on the same page. And then I'm going to start talking about Knative and go through a bunch of demos about Knative. Now, when you talk about serverless, depending on who you talk to, you get different definitions. On one spectrum, people say serverless is just a function that you define that gets triggered, and that's it. On the other hand, anything that can be like a service, where you don't have to worry about service, can be serverless. But I think, for me, when I think about an ideal serverless framework, there are certain pillars that I look for. And these pillars are, first of all, I shouldn't care about servers. Obviously, there's servers somewhere, but it's not my problem. I want the serverless framework to be idiomatic, meaning if I am a Java developer, I'm probably using Spring Boot. I like to use Spring Boot even in a serverless context. If I'm a C# developer, I'm probably using ASP.NET Core. I would like to use that still in my serverless framework. Whenever we talk about serverless, it's usually event-driven, so something triggers our function or container. And finally, it would be nice to have this serverless framework that you're using to be portable, so that you can take your function or container and deploy to multiple places. So when you look at Knative, I think it does a pretty good job in satisfying all these pillars that I look for. And hopefully by the end of this presentation, you'll see why. Now in terms of Kubernetes, I mean, people who run Kubernetes, they already know this. But if you want to write a microservice and deploy it on Kubernetes, you need to do a lot of things. First, you need to containerize your application and have a container image deployed to somewhere like Docker Hub. Then you need to create a pod template, which is usually a pod is a single container usually, but it can be multiple containers. Then you need to tell Kubernetes what you want to be true. In this case, we are saying Kubernetes that there's a replication controller, and we want to have 3 replicas, so we want to have 3 copies of our pod. Then Kubernetes looks at the nodes, the servers that you have, and it will create the pods, it will schedule them. And then once you're ready to expose these pods to the outside world, you create a Kubernetes service, which has a stable virtual IP, and people from outside will get to the service. From there, we'll get to the pods. So as you can see, there's a lot of things that you need to do to get your service up and running on Kubernetes. It's not impossible, but it's a lot of steps, right? And if you're an application developer, you really don't care about all of this, or at least you don't want to care about it. So that's why application developers, they love serverless, because they can just write their code, deploy their code, and not so much care about how that code is running under the covers. But at the same time, if you are an operator, you love Kubernetes, especially if you need to run containers, because operators, Kubernetes gives all these building blocks that operators need to run containers at scale and in a resilient way. So I feel like there's this tension between developers not wanting to care about Kubernetes, but at the same time operators wanting to use Kubernetes. And Knative, it's all about bringing these two worlds together so that you can still use Kubernetes, but also you can abstract it away so that application developers, they don't necessarily care about the fact that there's a Kubernetes under the covers. So Knative, it's a GitHub project. It's an open source GitHub project. It came from Google, but now a bunch of companies like Red Hat and IBM and SAP and others, they're contributing. And you can think of it as a way of, it's like a set of components, basically, to turn Kubernetes into serverless. And we'll go through those components one by one. All right, so the Knative stack kind of looks like this. So at the base level, the platform level, you have Kubernetes. Everything runs on top of Kubernetes. Then on top of that, you need to install a gateway. Knative, it doesn't try to solve networking problems. So it doesn't try to figure out how to get traffic from outside to your pods. Instead, it relies on a gateway like Istio or Glue or Ambassador to do that. Typically, it's Istio because that's the most fully fledged gateway people use. But it can be a little bit heavyweight, and some people prefer Glue or other gateways. So Knative keeps adding new gateways with every new version almost. But either way, you choose the gateway you want. Then on top of that, you install Knative. So there's Knative Serving and Knative Eventing. And there used to be something called Knative Build as well. But now Knative Build ended up being a separate project called Tekton Pipelines that I'm going to talk about later. So you also usually use Tekton Pipeline with Knative, but it's not really part of Knative anymore. So that's Knative, and you can use it as is anywhere you run Kubernetes. But then typically, if you are running in cloud somewhere, you would use other products that are being built on top of Knative. For example, on Google Cloud, there's something called Google Cloud Run, which is the managed version of Knative. So it's Knative, it implements Knative API, but it's managed so that you don't have to worry about the cluster underneath. And there's another version of Cloud Run called Cloud Run on Anthos, which is Knative on Google Kubernetes Engine. And there's other products from other cloud providers that are being built on top of Knative. Now, today's talk is about Knative pure, like as if you're running it by yourself. But as I mentioned, if you're in the cloud, you're probably going to be using something else on top of that if you want to. Now, how do you use Knative? Well, first you need a Kubernetes cluster with some gateway. So on Google Cloud, you run a single command, gcloud container clusters create. Then you specify an add-on, and in one of these add-ons, we are saying Istio, and then we specify things like where I want my cluster, how many nodes, things like that. But basically, at the end of this command, you will have a cluster with Istio already installed on Google Cloud. Then you need to create a cluster role binding for Knative to manage your traffic. Then you need to install Knative on top. And installing Knative on top is basically just pointing to some YAML files that Knative comes with. So 0.9 is almost the latest version. 0.10 just came out 2 days ago, and I haven't updated my slides yet for that. But basically, in this case, I'm installing 0.9, and I'm pointing to serverless.yaml to install Knative serving. I am pointing to eventing release.yaml to install eventing. And then there's also some monitoring that comes with Knative. You can install that as well. But you don't have to install serving and eventing at the same time. You can pick and choose what you want. So it doesn't have to be like all Knative or not. So let's actually take a look at this. So this is my Google Cloud. I already created a cluster, a Kubernetes Engine cluster, which is a managed version of Kubernetes on Google Cloud. I already installed Istio on top. And then I also installed Knative 0.9 on top. So I just want to make sure that actually Knative is working. So Knative is just another app running on top of Kubernetes, but it gets installed into separate namespaces. So I just want to look at Knative-serving namespace and see that the pods for Knative are running, and they are. And then let's look at eventing as well. So the eventing pods are running as well. So that's good for our demos. Now I want to talk about Knative serving first and let you know what it is, and then I want to show you some demos on Knative serving. So Knative serving, in a nutshell, it's a way to deploy containers in a serverless way. And what I mean by that is that if you use Amazon Lambda or Google Cloud Functions, what you do is you create a function, and you just deploy that function, right? And you don't really care about anything else. And everything, all the details of that function, how it's deployed, how it's auto-scaled, how the traffic goes to that function is all done for you, right? So Knative is the same way, except the unit of deployment is a container. So instead of deploying a function, you're deploying a container. You're giving a Docker file, and you're just saying, deploy this container. And then all the things that you expect from a serverless function, it happens with Knative serving for containers, right? So what you get is that you get your container deployed in a pod, you get traffic sent to it, you get automatic scaling by default. So everything by default scales down to 0 if you don't use it, but then if you use it, if more people use it, it scales up to n. You get a basic configuration and revision management that I'm going to talk about. And then once you have multiple revisions, you can do traffic splitting. So you get some kind of basic traffic splitting with your revisions. So the Knative serving terminology kind of looks like this. At the top, you have a service. This service is not a Kubernetes service. It's a Knative service. So it's a separate service. And then the service has a configuration. In this configuration, you specify the image that you want to deploy, and you specify things like the environment variables that you want to include in your container. Then you deploy the service and the configuration bundled together, and that creates a revision in Knative. And then the route, and Knative also creates a route that points to that revision, meaning all the traffic goes to that revision. Now, every time you change anything about this configuration, that creates another revision, and it updates the route to point to that revision, right? So that's the way it works. But at the same time, once you have multiple revisions, you can also set complicated rules here and do traffic splitting. So you can say 50% of the traffic goes here, the other 50% goes there, or other things like that, right? So in a nutshell, this is what Knative serving is. So let's actually look at some examples. So as I mentioned, all of this stuff is on GitHub. So feel free to go to my tutorial. And then here I show you how to deploy and install Knative on Google Cloud. And then these are my samples. So I just want to go through some of these. For example, I want to just start with something very simple, hello world. Let's say we have a really simple service, and when it gets a request, it will just reply back with hello world and some version number, right? So I write my code. I have code in C# and Python, but you can write it in any language you want. Then I create a Docker image, and then I push that image to Docker Hub. And then to create my service, I need to create a YAML file. And in this YAML file, the first thing that you're going to realize is that we are using Knative API. So it's not a Kubernetes service. Even though the kind here is service, it's actually a Knative service. The name is hello world. The default namespace, that's where this service is going to be deployed. And then this is the configuration of my service. And in this configuration, we are pointing to my image that I pushed on Docker Hub. And then I'm also passing an environment variable called target with version 1. So this is the variable that I'm going to read in my code, and I'll just say hello v1. So to deploy the service, we'll just kubectl apply, just like any other Kubernetes construct. Let's actually do this and see what happens. But here I'm going to watch some things. I'm going to watch Kubernetes pods, Knative service, configuration, revision, and route, and see what happens. So right now I'm watching things, but nothing is happening because I haven't deployed anything yet. And in here, I have some service definitions. So let's just deploy the first version of my service. Now this deployed the Knative service. And then you'll see that immediately this created a hello world service with a URL. It created a configuration. It created the first revision of my service. So this is the first generation. And it also created a route that points to that revision. I should also mention that I set up domain to point to nip.io. It's a dummy domain DNS service that I'm using, but you can set your own proper domain if you want. So once we have this, if I do a curl, then it says hello v1. So my service is up and running, the network is already set up, and then everything is working for me. So you can see that deploying a Knative service is just defining a YAML file, pointing to your image, and just doing kubectl apply, and that's it. It's very simple. Now, as I mentioned before, let's close this. every time something changes here, it creates a new revision. For example, if we go to our service and change this environment variable from V1 to V2, so we are making a configuration change, this will create a new revision to our service. So let's actually do that. So here, let's apply V2. Now you'll see that immediately Knative will realize that something changed. It created a new revision, so this is generation 2. And then it also created a new pod for my new configuration change. And then if I do a curl again, now it says hello v2. So we did a configuration update. If you want to change your code, it's the same way. Let's say you want to change your message from hello to bye. You go to your code in C# or Python, you change your code, then you build an image, and this time I give my image version 1 to version 3. I just update my version number. Then I go to my service, and then I update my image from version 1 to version 3, and I also update my environment variable, so I know which one I'm hitting. So this is how I do a code update, and let's deploy this. Now this is like doing a code update. And you can see that, again, it created a new container, it created a new revision. But you can see that now we have 2 pods running. One is for version 3, the other one is for version 2. Version 1 is gone because we haven't used it for 60 seconds. And because of that, it's scaled down to 0. So we have auto-scaling. And when things are not used, things scale down. And if I go back here and do a curl, now it says by v3. So we did a code update. Of course, in the real world, you don't do code updates like this. What you want to do is you want to deploy a service silently. You want to test that URL, make sure that it works, and then maybe after that you want to send some traffic to it, make sure that it works, and then once everything that you're certain is working, then you can send all of the traffic to that. So you want to do like blue-green deployments or traffic splitting or whatever you want to call it. So to do that, Knative has some traffic splitting features. So what you can do is, like, first thing to mention is that the revisions that we have right now, if you look at here, they have like random names, right? These are the random names for revisions. It's actually nice to have predictable revision names so that you can do traffic splitting between those names. And to have predictable version names, what you can do is that you can go to your service, and then under here, you can give it a name. And you can say, this service with this configuration will have hello world-v1. That will be its name, right? That way, I can use it in my traffic splitting rules. So then you can go to your service and then create some traffic rules. Now, in here, what I'm saying is that I want the current version to be this revision that I just defined. And I want it to get 100% of the traffic. And then anything that goes after it, so any latest revisions, should get no traffic. So anything I deploy after this revision should be deployed, but it shouldn't get any traffic. So I want to do silent deploys. That's what I'm saying here. Let's actually do this. So kubectl apply, service v1, pinned. So now this goes back to version 1 of my service, but this time you will realize that the version 1 has a name. It's a predictable name. And then if I do a curl again, now we're back to version 1. Let's deploy another one, this time version 4. And this version 4, again, you'll see that it has version 4, a predictable name, but it's not getting any traffic. It's deployed, but when I do a curl, I'm still doing hello v1. I did a silent deploy. Now, if I go back to my URL, and then at the beginning, just say latest dash, now I can get to hello v4, right? So I can get to that service, the latest version of my code, I can test it out, make sure it works, and then when I want to send traffic to it, I can send some rules and send some traffic to it. Now, to send traffic, all I need to do is go back to my service, and then under traffic, in here, I'm just basically saying that I want version 1 revision to get 50%, and I want the other version, version 4, to get the other 50%, and anything after that should not get any traffic still, right? So if we do this, service v1, v4 split. Now you will see that nothing new got created because we have version 1 and version 4 already. We already have the pods running. But now if I do curl, you see it says version 4. If I do another curl, now there's a little bit of wait because version 1 pod is scaling up. Now it's version 1. And if I do it again, you can see it's like version 1, version 4, which is pretty nice. So all of this kind of stuff becomes quite easy with Knative. I should also mention that the auto-scaling is quite configurable. So what I want to show you here is that I have this service that I created. I call it sleeping service to simulate some traffic, some work. So when it gets a request, it just sleeps for 4 seconds, and then it responds back with hello world. So we will use that as a way of showing auto-scaling in Knative. So let me just deploy this first, and then send some traffic to it, and then I'll explain what it is. So first, let's get rid of our hello world Knative service. So now I deleted hello world service, and immediately should clear things up. Then let's go to sleeping service, and then I will just apply this service. So this creates the new sleeping service, and you can see that my sleeping service has a single pod right now. And then I want to send some traffic to this and see that auto-scaling will work. So to send the traffic, let me just copy this here. I'm using a tool called Fortio to just send it some load. I didn't copy it properly. Let's do it properly. All right. So this will send some traffic. And then as that's happening, let me explain to you what I did here. So I created my sleeping service that simulates some traffic, some work, and then I set some auto-scaling rules. So if you go to your service, and then under annotations, here you can set some auto-scaling rules. The default auto-scaling in Knative is concurrency-based auto-scaling, which means that each pod will get 100 requests before it scales up. So for 100 requests, it will be 1 pod. For 101, it will be another pod. It will be 2 pods. But that auto-scaling is configurable. So in here, I'm setting target to 1, meaning I want 1 request per pod for whatever reason, right? So if I have 2 requests, I'm going to have 2 pods. So that's configurable. The minimum and maximum scale are configurable as well. So by default, if you don't use your pod, it will scale down to 0. But sometimes you don't want that. Sometimes you want your pod, you want to have a single pod running at all times because maybe you don't want to have cold starts because it's expensive to start your containers. So in this case, I'm setting my minimum scale to 1, meaning I will have 1 pod running at all times. And I'm setting maximum scale to 5, meaning I will have 5 pods running at max and not more, right? And then the type of auto-scaling is also configurable. So if you don't like concurrency-based auto-scaling, and if you want to do CPU-based auto-scaling, you can comment that out and comment this in, and this will do Kubernetes' CPU-based auto-scaling. But my experience is that the concurrency-based auto-scaling, it reacts faster, especially for web kind of workloads. So this is what I'm using here. And then, yeah, so I deploy my service, and then we are sending some traffic, and then you can see that the sleeping service now has 5 pods running because it's scaled up, right? Because it's getting some traffic. So if I kill this, then I will show you later that this will scale down to 1 basically, and we'll have 1 sleeping service running. So that's how you can configure auto-scaling in Knative. All right, that's that. Now, so what we did so far, by the way, my timer doesn't work, but I think I'm still on time, right? Yeah, I have a lot of time. So far what I show you is that Knative on Kubernetes. So every time you have Kubernetes, all of these features, they will work. But then if you are running on Google Cloud, you probably want to run Cloud Run. It's the fully managed version of Knative. And it makes it even easier to run these services. So I just want to quickly show you how that works so that you get an idea of how Knative experience looks like on Google Cloud. Now, for Cloud Run, first of all, you need to use it in a region that's supported because it's a beta feature right now. So these are the regions where it's supported. And then you need to push your container image to Google Container Registry. Google Container Registry, it's a private space for your Google Cloud project to save container images. And then if you just run gcloud build submit and then tag it this way, this will build your Docker image in the cloud using Google Cloud Build. It's a service that builds Docker images, and then it will save it to Google Container Registry, some private space for your service. So I already did this, and then once you have your image in the cloud, you just run a single command, gcloud run deploy, and point to your image that you just pushed. So let's just copy this, and then I should also show you that here in Google Cloud, I go to Container Registry, and under here I have some images, but if you look at Hello World, there is a V1 here, so that's the image that I pushed before this talk, 19 hours ago. So let's just deploy that. So to deploy that on Google Cloud Run, by the way, you can see that the sleeping service is already scaled down to 0. Actually, let's just get rid of this service because I don't need it right now. All right, so we deleted that. Now, oh, sorry, I need to copy this. So this is the command to deploy to Cloud Run. And then it's asking me, where do you want to deploy this? There's different versions of Cloud Run, the fully managed version, the one that runs on Google Kubernetes engine, or a pure Kubernetes cluster. I want to choose the fully managed version. And then it's asking me which service name you want. The service name is Hello World. And now it's creating a revision and creating a route to point to a revision. So all the things that I showed you with Knative, it's happening. And it's deploying it. And within a few seconds, we'll have the service running. But the big difference in this case is that we didn't create a Kubernetes cluster. We didn't install Istio. We didn't install Knative. We didn't do any of that. We just said deploy this image to Cloud Run, and that's it. So if we go back to Cloud Console, and then in here now, instead of looking at Kubernetes engine, I'm going to look at Cloud Run. You can see that I have some services, but this Hello World service is the one that I just deployed. And then you can see that first of all, I get a default URL for my service. And if I click, it will say Hello V2. So it's the same as before. I get some graphs for my service. By default, I can see the revisions on my service. This one we just deployed right now. I can look at the logs. So the logs integrate with what's called Stackdriver on Google Cloud so that I can see the logs in here easily. And then if I look at the YAML file, the YAML is basically a Knative service, but it's managed Knative for me so that I don't have to worry about clusters and managing clusters and all that kind of stuff. So that's the nice thing about Knative. And there's much more detail about Knative, authentication and also, for example, you can set how much resources it needs to use, like memory and CPU and all that kind of stuff, and maximum requests. But I'm not going to talk about that because this talk is about Knative, so I'll continue on Knative. But just know that Cloud Run is there in case you are running on Google Cloud. All right. And then the last thing that I want to mention in terms of Knative services is that right now, everything you deploy as a Knative service, it has a public URL, right? So anyone can get to it. But sometimes you don't want that. Sometimes you want an internal service where only other services within your cluster can call. To do that, you can actually go to your service and add a label. And then in this label, you just say cluster local. And this basically turns your service into a cluster local service. So it's very easy to create internal services. And actually, we can take a look at this. I think I have one. So if you look at Hello World, and then service local. Now this creates a cluster local service, and then you'll see that the URL of this service, it's not a public URL. It's a Hello World local default, so it's a cluster local URL. And people inside the cluster, they can get to it, but from outside, they cannot get to it. And then if I remove the label, it will be turned into a public service. So it's very easy to make something private or public within Knative. All right, so let's delete this. And then I can kill this. All right, so that's cluster local, and I think that's all I want to show in terms of Knative serving. Now, the second part of Knative is Knative Eventing. And Knative Eventing, what it tries to do is that it tries to connect a lot of different event sources to a lot of different event consumers using some kind of flow in the middle. And this is a very generic explanation, but it's on purpose because Knative Eventing, it tries to be very generic. And it tries to connect a bunch of different things together. So in terms of what you can listen, event sources, these are some examples. So you can listen Kafka messages, you can listen AWS messages, you can listen Google Cloud PubSub messages, you can listen cloud storage events, Kubernetes events. I mean, this is not the full list. The full link is down there. But there's a lot of things that you can listen, and more are being added in every release. And the way it works is that, so when you, in Knative, when you install eventing, you get these things called sources. So these sources, they should be called source importers, but basically they import external events, like PubSub messages or whatever, into your cluster, and then they pass them into a broker. So every namespace will typically have a broker receiving the messages for the namespace. So the broker in the namespace will receive the messages, then it will pass it to something called triggers. In triggers, what we are trying to do is basically connecting the namespace messages into specific services. And these services, they are either Knative services or they can actually be Kubernetes services as well. It doesn't have to be anything specific, but it's something that can be addressable. It's something that can be called. So the trigger will do the connection, but it will also do some kind of basic filtering so that not all messages end up in the same service, right? You want certain messages to get certain services. So that's how you set up with trigger. So from source to broker to trigger to service, that's kind of how it works in Knative. And I should also mention that there's a lot of different kinds of messages in Knative that you can listen, but then they eventually, once they get into Knative, they get converted into what's called cloud events. And these cloud events, they're CNCF, open source definition of events. It will have some specific metadata associated with them, and then the data part of this cloud event will have the actual message that you're interested in. And then from then on, from this, once it gets into source to broker, it will be cloud event that you can deal with. All right, so I have one example of this that I want to show you. So in this example, what I did is that I tried to connect Google Cloud Storage events to Google Cloud Vision API using Knative Eventing in the middle. So the way it works is that users, they send some pictures to a bucket that I defined, and then once these pictures are saved, this bucket can emit a PubSub message, so you can configure it so that it can emit some PubSub messages. And then this topic is a PubSub topic in Google Cloud. I'm listening with Knative Eventing, so these notifications are pulled into Knative Eventing. Then from there, we'll go to broker trigger, but it will eventually end up with a Knative service. And then in the Knative service, I make a call to Vision API, and I label these images. Vision API is a machine learning API that, given an image, it can tell you what that image is about. So I'm using that, and I'm going to log it out. But the important thing is that I'm connecting cloud storage events, like saving an image, to a Vision API call using Knative Eventing. So to do this, first, you need to write the code. I'm not going to explain the code. You can take a look at it. But it's basically just you have an image, and it just makes a call to Vision API and gets the labels and logs it out. You can take a look. And I create and push the image. Then I create my Knative service. And in this case, I just point to my image. So there's nothing specific here. Then I need to create a... So here I'm listening Google Cloud PubSub messages. So for that, there's something called pull subscription that kind of pulls the messages, Google Cloud messages, into Knative. So the pull subscription, you specify the topic that you want to pull messages from, in this case, testing, and you also specify the sync that you want. In this case, it's a Knative service, but it can also be a Kubernetes service as well. So that's how you configure that, and let's actually do this. So let me go to my eventing samples. And I have more samples here, but you can take a look at it yourself if you're interested. So first, let me define my, let me start my Knative service. So this will create a vision service, and then I will create my pull subscription. This will pull the messages from PubSub into Knative cluster. And then if I actually look at kubectl get pods, you can see that I have my vision pod running, and I have also my PubSub. So this is the source that's listening for messages from PubSub, right? And if you look at the logs of this, let me copy this command. So I want to look at the logs of my pod. You can see that it's just a service waiting for something to happen, nothing specific. Now, to trigger this, we need to actually send a picture and get it triggered through the chain. So let's do that. So let's go to Google Cloud Storage. And then this is my Knative bucket that I created beforehand. I already enabled notifications on it, and I already have some pictures. Let's upload the same picture again. So eventing, vision, pictures. And this picture, it's hard to see, but basically it's a beach with mountains and sunshine. So let's just upload this. And I will replace the existing object, okay? So now what's happening is that this is going to cloud storage bucket that will trigger a message that says, oh, there's a new image that's been saved to a topic. And then that topic is being listened by Knative. Knative will pull that message in, and then it will pass it to a Knative service. And Knative service will make a call to Vision API, and then will label that image. So if everything worked, yeah, we can see that our service received the message, and then from there, it extracted the URL on my beach.jpg, and then it's hard to see probably at the bottom, but it says this picture is labeled sky, body of water, sea, nature, coast, water. So it basically extracted these labels out of this image. But the important thing is that we connected two things that are not related to each other, like storage events to Vision API. And there's a lot of things that you can connect using Knative Eventing, and that's the whole point of it. All right. Cool. I don't know how much time I have. I think I have 10 more minutes. Now, the last part I want to talk about is building. So before 0.8 of Knative, which was 1 or 2 months ago, there used to be something called Knative Build. And it was all about building container images and storing them somewhere like Docker Hub. But then that turned into a new project called Tekton Pipelines, which is basically a way of running pipelines on Kubernetes. And in these pipelines, you can do building images, but you can also do other things, right? So they kind of generalize Knative Build into Tekton Pipelines. So that's why I don't talk about Knative Build anymore, but in my tutorial, there's a section for it if you want to. But you can do everything with Tekton Pipelines, and that's why I'm focusing on Tekton Pipelines now. Now, in Tekton Pipelines, again, as I mentioned, it's a way to build pipelines on Kubernetes, and you can use it to build container images and use them in Knative, right? So in Tekton Pipelines, there's this notion of task. A task is the thing that you want to do, like building an image. Then you run that task using a task run. In task run, you are basically providing inputs and outputs from your task, right? So if you want to build a container image, your input will be what you want to build, your source code, and then your output will be where you want to save that image, right? So you provide that to your task, and then you run it in a task run. You can chain multiple task runs into pipelines, and then you can also use service accounts to authenticate with things like Docker Hub. So that's the kind of things that you can do with Tekton. So I just want to show you, again, some examples of this. First of all, to install Tekton, you need to just do kubectl apply and point to a YAML file. And then once you installed it, so let me make sure that I have my Tekton running. So it's in a separate namespace, Tekton Pipelines, and you can see that my Tekton Pipelines pods are running, so that's good. If you want to test it out, you can do a very simple task. For example, in this case, we are defining a task called Hello World, and then you can specify the steps here. So my step is basically just using the Ubuntu image. I'm just going to do echo Hello World. So I'm not doing anything. I'm just saying echo. And then this defines what I want to do, but then I actually need to run it. And to run it, I need to create a task run. And in this task run, I give it a name, but I point to my task reference that I just defined. And then to run these, you will just say, create the task and run the task like this. And in the end, you should see it running, right? I won't go through this because it's really basic. But what I want to show you is doing an image build, actually. So let's try to build a container image using Tekton Pipelines. And before I do this, let me actually start this process so that it actually works. And then we can take a look at it. So what I want to do here is that let's go to build. And here I have some tasks. So let me just first create my task build. So I have a task to build container images. So I'm just kind of creating the task. And then I want to now use that task in a task run. So I will say task run, and then build. And I want to push to Google Container Registry. So that's one. So you can see that this creates two pipeline. Well, it didn't create them because I had them before, but there's two pipeline resources that I'm going to use. And the task run is also created. And then let's do another one for Docker. And this also kicks up Docker run. So if I do kubectl get task, you can see that I have a task. And if I do a task run, you can see that I have two builds that are being working right now. One we will push it to Google Container Registry, and the other one will push to Docker Docker Hub for my image. So let's now look at how we do this. So this task, in this task, I'm basically using an open source project called Kaniko to build Docker images. Kaniko, it's a way to build Docker images without having to have Docker host yourself. And I won't bore you with the details, but basically this sets up Kaniko. This uses the image of Kaniko, and then it sets up the things that Kaniko expects with the context and everything to build an image. So that's my task. And then the task run, the thing that I want to run, first defines two pipeline resources. The first pipeline resource is my source code, what I want to build. So it's pointing to my Knative tutorial. So that's the code that I want to build, the Docker image. And then the second one is where I want to push my image. So here I'm pushing it to Google Container Registry, right? That's what I'm defining here. And then you can see that it's Hello World, and then the version is Tekton. I call it Tekton so I can see it. And then in the test run, I'm basically saying that for my input, use my Knative tutorial source. And then for my output, push it to where I defined, so in my pipeline resource. And then I kick off my build. And then if you look at your pipeline, Tekton Pipelines, you can see your tasks and task run and pipeline resources. But in the end, basically, you will have a pod, and we can actually take a look at this. So if we do kubectl get pods, you will see that I have some pods running that's actually doing the build within my cluster. Obviously, you won't do this in real life. You will have a separate cluster for building things. But here we are doing a demo. And in the end, when everything works, we should see it, the image pushed to container registry. So if you go here, I don't think it's completed, but let's take a look. Yeah, you can see that I have a Tekton one but it was pushed 4 days ago. So once it's finished, it will be pushed here. And the very last thing that I want to show here is that if you want to do this against Docker Hub, you need to authenticate. So for that, you need to create a service account. So in Kubernetes, there is this notion of secrets. So you can create a secret with your username and password or Docker Hub credentials. Then you create a service account to refer to this secret. So that service account will use that secret. And then when you design your task run, it's the same thing, except in your task run, you refer to a service account. So this is the service account I'm referring to. And this will authenticate with Docker Hub and push it to Docker Hub, right? So this is how you can do things with Tekton. By the way, you don't really define tasks like this. Usually you use someone else's task. So there's this notion of task templates. So for example, Kaniko, I use Kaniko, right? Kaniko has a task already that I can use. So I can actually get the task that's already defined for me. And then in my task run, I will just refer to that task, right? So that's what you usually do. You let projects like Kaniko create a task for you, and then you use that task in your project. But you can also create your own task, like I did, and do it that way as well. So it's up to you, but usually there's a template already out there that you can use and, in your pipelines. I think that's all. Yeah, I have 2 minutes. Let's see. Yeah, that's all I have. So as I mentioned, all this stuff is on GitHub. This is the page for Knative, knative.dev. And if you want to run it on Google Cloud, cloud.google.com/run is the place to go. And I think we have 2 minutes, so if you have any questions, feel free to let me know. There's a microphone there, so please take the microphone.
Hi.
Hey.
Thank you for your talk. I would like to clarify one thing with after scrolling. For sleeping service, you specify one request for one pod, and you specify minimum 1 and maximum 5 pods.
Yes.
What's happen if you have more than 5 requests? They will be wait, or they
they will be waiting, basically.
And some timeout, we can specify this timeout in configuration.
I think there is a certain amount, I don't know exactly how long, but they will be waiting, say, like 60 seconds or something, and then my service waits only 4 seconds, so after 4 seconds they will be responded back. But if there's too many requests waiting, then at some point some of them will get errors from Knative.
And it's possible to configure this timeout. I mean, for example, if we have some time frame that we shoot in, I don't know, 3 seconds, and when we need to specify for every pod.
Yeah, I'm not sure. I don't know, actually. I have to check. I mean, a lot of things are configurable in Knative, but I'm not sure if the request timeout thing is configurable. It should be, because at the end of the day, it relies on Istio under the covers to do all this work. And Istio is very configurable, but I don't know for a fact whether it's configurable or not.
Yeah. And I have one more question about Cloud Run. It's run container on every request. For example, we have web server which handle two URI.
Yeah.
And what's happened when we have two requests to this specify, for example, to one URI and another request to another? It's run two containers, or it run one and kind of redirect the second request to the kind of first container.
So by default, each container will get 100 requests. Right? So it's kind of like multi-threaded. I mean, they will get 100 requests, but it also depends on your configuration. So if you make your target 1, then for the second request, it will create a new pod and it will send it to that there as well. So it depends on your configuration.
And we can do this in this YAML. When you for sleeping service, you specify it's kind of how much requests it can. We can put 100, and it can handle 100 requests in one. So
it's all done in YAML. So in YAML, you configure it, so you just change YAML and apply that, and it will change the service to whatever you specified. Yeah.
Understand. Thank you.
Yeah, you're welcome. Any other questions? Okay, thanks very much.